Hello everyone. Today I will be presenting an analysis on global unemployment. So, we will begin with introduction. Unemployment is a critical socio-economic issue that affects countries worldwide. So, the objective of this project is to conduct an exploratory data analysis on global unemployment data. So, in this analysis, we utilized comprehensive global unemployment data. The dataset approximately contains 1200 rows and 16 columns, including key fields like country name, gender, age group, and yearly unemployment rates from 2014 to 2024. In this, our approach was systematic. First, we cleaned the data by addressing missing values using median imputations and removing duplicates. So, we also used Z score analysis to identify and handle outliers. The clean data was then explored using descriptive statistics and visualizations such as bar charts and heat maps to understand trends and relationships. EDF was a crucial step in this analysis, which focused on identifying patterns and correlations using various tools, including bar charts, pie charts, KDE plots, and heat maps. So these visualizations helped reveal meaningful trends in the unemployment data. From our analysis, we observed that women faced significantly higher unemployment rates in countries like Pakistan and India. So 2020 saw a very sharp global increase in unemployment rates due to COVID-19. So European countries like Greece and Spain also show high unemployment rates, while Asian countries like Japan has some of the lowest rates. So in conclusion, the analysis provides a data-driven perspective on global unemployment trends over the past decade. It highlights key patterns such as gender disparities and the pandemic's impact, offering valuable insight for policymakers and researchers. So, this is the report of my project, Exploratory Data Analysis of Global Unemployment Data. In this report, I will tell you how I implemented this project. At first, I did the data preprocessing. I handled the missing data, removed duplicates, and removed outliers. After that, I plotted different graphs, bar charts, and pie charts, and pair plots to visualize the data and identify relationships between them. So, as you can see, this bar chart shows the top 20 countries by average unemployment rate. This is also a stack bar chart that shows unemployment rate by year 2014 to 2024. This chart shows average unemployment rate by age group. So this is a pie chart. This pie chart shows that 54.7% females were unemployed while 45.3% males were unemployed. The bar chart shows the analysis of unemployment rates segmented by age groups and gender. The KD plot shows whether the data is normally distributed, skewed, or multimodal. As you can see, I also plotted pair plots. I also created a heat map to examine correlations between unemployment rates across years 2014 to 2024. Then I also plotted the distribution of data from 2014 to 2024 using a histogram. So this is a line plot that shows the yearly trend of average unemployment rates over 2014 to 2024. After that, I plotted a line chart that shows that 15 to 24 age group consistently faces the highest unemployment rates, especially peaking in 2020 due to pandemic. In contrast, the 25 plus age group has the lowest rates, including more job stability. You can see this from this graph. After that, I plotted the scatter geomap. It helped us in visualizing global unemployment rates for different countries. I also plotted strip plot to observe the spread of unemployment rate within each age category. This is the violent plot that shows how data is distributed. This tree map is used to visualize the unemployment rate across different countries, age groups, and years. The goal was to explore patterns and trends in unemployment. So, after that, I also did basic statistical analysis for each year. You can see from this, I calculated mean, median, mode, standard deviation, range, variance, quartile deviation, and mean deviation. I also calculated moments. So you can see from this picture. After that, I plotted the graphs to know that whether the data is positively skewed, negatively skewed, or symmetrically skewed. So in this dataset, my dataset is positively skewed. Data is positively skewed. So I also plotted uh, Curtis's visualization to know whether it is leptokurtic, platykurtic, or mesokurtic. So we came to know that data is leptokurtic. So this is the code of my project. At first, I imported the necessary libraries like pandas, numpy, matplotlib. After that, I loaded the dataset. Then, this is the code of the data preprocessing. I handled the missing values, removed duplicates, removed outliers. After that, I plotted various graphs like bar charts, pie charts, and pair plots as I explained earlier in the report. These are the codes of this plot, the distribution, this plot, this function plot, pair plot, this function shows the line graph that shows the unemployment trend over years. So this is the code of the bar chart that shows the top 10 countries by average unemployment rate. This is the code for the pie chart that shows the pie chart for gender unemployment rate. Okay, after that, this is the code of the box plot, the KDE plot, stacked bar chart. So after that, this is the code of the correlational heat map. I will also show you the results below of this code. This code plots the scattered geomap. Now I will show you the results of this code. So yes, so as you can see, I also visualizes the missing values. This shows the missing values in the data. As you can see, this space, the white line between the data. So this represents missing values. After that, I also plotted the different various graphs, the distributions, the pair plots, the yearly trend of average values, correlational metrics, box plots. Wait, I will show you. This is a pie chart. So these are the distributions and KDE plot of each year that shows the average unemployment rate. So wait. So this shows the unemployment rate trends by countries. As you can see, these lines. This shows the countries, different countries. After that, I plotted the bar chart that shows the average unemployment rate by gender, that how much the female contributed and how much male contributed. This is the correlation matrix. This is a box plot, the comparison of age and gender for unemployment. This is the scatter plot that shows This is the code of the violent plot that shows how much the data is distributed. As you can see from this, see this. This is the code. This data shows the pair plot. It helps us to visualize the relationship between different age groups in years between 2014 to 2024. So this is the map. So this shows the global unemployment rates in 2024. You can see when you put the arrow on the map, it shows the name of the country and the average unemployment rate. For example, I will show you like this. South Africa. Country name South Africa. Average unemployment rate in 2024 is 23. So I will show you the maps of the rest of years. Wait. These are the map of the rest of years from 2014 to 2023. Same like previous map, it shows the average unemployment rate of each country whenever you put the arrow on the map. Now I will show you basic statistical analysis. So as you can see from this code, I first loaded the datasets and then selected the columns that I want to show the statistical analysis. So first I calculate mean, median, mode of the unemployment rates, then quantile, mean deviation, coefficient of variation, coefficient of standard deviation, skewness, kurtosis, see this. Yearly statistics, year 2014. This shows the yearly statistics of year 2014. All the necessary statistics. This shows the moment of all the years. After that, I plotted the graphs to show whether the data is positively skewed, negatively skewed, or symmetrically skewed. So as you can see from this graph, it is positively skewed distribution of all visualizes this of all years. So you can see from this. After that, I plotted the graph to visualize kurtosis, whether the curve is leptokurtic, platykurtic, or mesokurtic. As you can see from this, it is leptokurtic. It is showing the value of kurtosis and yeah, so that's it. This is my complete project of exploratory data analysis of global unemployment rate. These visualizations collectively provide a comprehensive understanding of global unemployment trends, enabling us to identify key insights and guide data-driven decisions. Thank you for your attention. So I also predicted the global unemployment rates. This part analyze global unemployment data, engineer meaningful features, and develop a machine learning model. I will show you how I did. I first loaded the data, did data pre-processing, reshaped the data using pd.melt function. After that, I also did data conversion and feature engineering. A new feature, unemployment change, was added to represent year-over-year change in unemployment rates for each country and age group. After that, I trained the model random forest regressor was used because of its robustness. After that, I evaluated the model using mean absolute error, mean squared error, and R squared error. You can see the result here. The result indicate that model performs well with a high R square value, suggesting that it explains 89% of the variance in unemployment rates. So after that I compared the result. A comparison of true and predicted unemployment rates was generated with a sample of first 20 results displayed. This tabular comparison highlights the model predictive accuracy for unseen data. After that, a line plot was created to visualize compared true unemployment rates with the predicted rates. Key observations include a close alignment between true and predicted values, confirming the model's effectiveness. Some deviations indicating areas where model predictions could be refined further. In conclusion, this project successfully built a robust model for predicting global unemployment rate. I will also show you the code. So this is the code of the predicting modeling. As you can see, I imported the necessary libraries, loaded the data, did data pre-processing. After that, feature engineering, model selection and training. Here you can see this part. Train the data, train the model and predict. After that, I evaluated the model and printed the results. I did the comparison of true and predicted values. I plotted the comparison using line plot. So overall, this was my project. At first, I did the exploratory data analysis on global unemployment data, and then I trained a model to predict the global unemployment rates. So overall, this was my project. Thank you for your attention.